how can we find hidden planets? The search for planets around stars other than our sun began in the 1990s. NASA's James Webb Space Telescope will make that search even easier. Normally, it's a real challenge to see planets around other stars. This is the best picture we have of one of these extrasolar planets, taken by the Hubble Space Telescope. No, not that. That's the star. The planet is, here. It's actually easier to see the dust around planets than the planets themselves, since there's so much dust spread out over such a vast area. This picture captures visible light from the star as it reflects off the planet and dust. But Webb's infrared vision will detect the inherent glow of these objects as they shine with their own infrared light. In fact, Webb will observe both gas and dust in exquisite detail around these young stars, studying and classifying showers of tiny pebbles as they ride lofting gaseous winds on a collision course with each other and eventually planetary destiny. Take a look at this animation. In the center is a heavy ball of gas in the process of becoming a sun-like star. Its gravity drags nearby gas and dust toward it. But because that gas is also zipping around the star, its motion balances the sun's pull and keeps it in a stable orbit. This also explains why Earth doesn't careen into the sun. Zooming into the disk, we see small particles in orbit. Because the star has drawn all this material together into the same space, things start to collide. Some particles stick together and develop a gravitational pull that collects more particles. Gradually, they form bigger and bigger objects, planets circling their own new sun. Astronomers now think that most of the stars in the galaxy have planets around them. We can't possibly measure or detect all of those planets, but by understanding how they form, we can begin to predict the diversity of planets out there, including how many Earths we can expect to find orbiting other stars.